Okay, a couple examples from the book. We're going to look at formulas for compound interest in this example, and in the other example, we'll look at the radioactive decay. These are all both very, very good real life examples in which you may use this information, 5 or 10 years down the road when you're just trying to do some math. Right here, we're going to look at this formula for compound interest. So right here, let's just take a look at this. We have P is going to be the principal, so that's how much money you start with. And let's say, you're trying to find a good bank and they'd give you a certain rate on how much money you get on it. So maybe it would be like 5% or something. That would be the R. That would be in decimal. So if it was 5%, it would be 0.05. And then this N is how many times they compounded a year. And then T is the number of years that you're doing this. So let's say we have an example where you get like 6% a year at a bank, and you start with $1,000. And after 1 year, let's say they will give you the 6% after in 1 year, so that it'll be like $60. That's what they would give you. Well, you could also ask them, well, could you compound it maybe once every 6 months? So do it twice, but only take half the rate. So let's look at that again, what I was just saying there. There we go. Okay. So let's, you said we started at $1,000 and we multiply it by the rate, and we would have got $60 of interest if we just did it once. But let's say I now ask them, okay, could you take my $1,000 and divide the rate in half? Okay, and then so you'd have 1,030, but could you do that twice a year? So now take this and multiply by 3. So your total amount would be 1,030 plus 30.9. Whoops, I'm sorry, that's 1,030 plus 30.9. And you'd have 1,060.9. You'd get yourself an extra dollar by doing that. So if you asked them to compound it, twice a year, but at half the rate, you'd get yourself an extra dollar. Well, that's what the problem is sort of doing here. It's saying, or the formula here is, you have the rate, and then you could say, well, could you do it like twice a year, but then do it twice in a row, or divide it by 2, but then multiply it by 2 times. So if we could do that, and then you could, how about maybe do it how about once a quarter? So do it 4 times, divide it by 4, but then multiply it 4 times. How about daily? That'd be even more advantageous. And the last one you could do is you could continuously compound it. Like you could do it like every millisecond or something like that. And if you did that, you would get an equation that looks just like this. You would actually have that E value that we talked about a little bit in the previous mini lecture. So let's go ahead and compare the values here. We're going to look at number 46. So we're going to use that equation that they have written there. So let's do that. So in this example, we're going to have, let's clear all this. Okay. So we started with $1,000. Interest rate is 6%, and we have 40 years to compound that money. Let's see what would happen is how much money we would have if we just compounded it once a year. That's what that 1 means. So we're going to use the formula. So A equals P, 1,000, times parentheses. We got 1 plus the rate divided by 1. So 0.06 divided by 1. And then we're going to multiply that by NT. So 1 times 40. Okay, you need all of those parentheses. If you're using an 83, you can't have any way to verify how I'm writing it. If you have an 89, it'll show up as a nice answer. Ooh, so it looks like I did this problem wrong, because you shouldn't just end up with $1,000. Okay, let's see where I made a mistake here. I see where I made a mistake. Okay, let's take this previous entry. Okay, I need to take this whole thing. Ugh. You can see I'm using this insert button here. So 1. Okay, so this is, got to get familiar with using the calculator here. So what I'm doing here is, again, I'm taking 1 plus 0.06, and then I'm taking that whole thing to the 40th, 1 times 40 power. And that whole thing is multiplied by 1,000. That's why I have all those different parentheses. Okay, that looks more correct. So I'm going to have, after 40 years, and I have 6%, that $1,000 became 10,000. We'll say 10,300 bucks. Not bad. So if you had $1,000 and you were 20 years old, you know, when you go to retire, when you're 60, then that $1,000 would have become 10,300 bucks. But let's say we can now compound it twice a year at half the rate. So all we're going to do now is we're going to change these 1s to a 2. So again, you can see it, again, we're taking half the rate, that's 0.06 divided by 2. Now we're going to multiply it twice as many times. So we have 2 times 40. We just got ourselves a little bit more money. We're now at 10,600 bucks. Okay, let's do it for 4. Let's do it for 12, 365. So that would be like quarterly, monthly, daily, and continuous. That's why they picked those different numbers. So let's do 4. Okay, the way I'm pulling this, the previous value up is, sorry if you can't see that, I press second and I press enter, and that says entry. So that's my previous entry. So that's how I'm pulling up my previous entry. So I put in 4 and I got 10,800 bucks. That's not bad. Okay, so again, I'm going to press second and I'm going to press entry, enter. And so now it comes up with my previous entry, and I can now just change the numbers around here. So it's just going to be, I need to insert a 2 there though. And then I'm going to take 4 there. Again, I'm going to write 1, but I need to insert a 2. Okay, so it's getting better. 10,009, we'll say $11,000. We'll round it. Okay, so now let's do it daily. So that would be now 365. So 365, 36, insert a 5. Whoops, why did I do that? There. Okay, 11,020 bucks, not bad. Okay, and the best I can do is to continuously compound that. So the equation there is going to be our principal, so 1,000 times, and then we have that e, so it's going to be second e with the natural log, that's the e. And then it is RT, so 0.06 times 40. And that is the most money we could ever get out of, so $11,023. If we continuously compounded our money, we had $1,000 bucks, 6%, 40 years. So when you go to the bank, hopefully you'll have some money later down the road, and you're going to want to ask how they compound that money. You can see that it is a difference, you know, 10,300 bucks if you only do it once a year, versus if they continually did it, or if they did it even daily. Daily would be just, I mean, almost just as good as continuous. So you want them to compound that money daily. Like right now I have money at Wells Fargo, and they compound their the money every quarter. I mean, every month. So that's not too bad. 11,000 versus 11,020 or 11,023. That's still pretty competitive. If they only compound it once a year, then you're definitely not getting your money's worth.